Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 4 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to find a true statement about this graph. Now, if we notice here, it didn't say in the problem, but we should notice, that's our big clue right there, that this is an exponential function. So y equals a times b to the x power. And just that standard form tells us an awful lot. So what do we know about this a term? Well, this a term, if we are dealing with compound interest and investment and savings, that's the principle. In general, we can say this is, in a word problem, this would be your starting amount. So it might be population growth, it might be you have so many toys, and then they disappear at a certain rate every day. There's always going to be some type of starting amount on those problems. But when it's just a raw equation like this and there's no written context, it's our y-intercept. So it is all three of these things, and we could just interpret it differently. Y-intercept, remember, is where the graph crosses the y-axis when x equals 0. How do we know that? Well, let's plug 0 into this equation up here. I'm going to say y times b to the 0. You remember that anything to the 0 power just turns into 1, right? So a times 1, look at that. Y equals a when x equals 0. So that's good to know. This b here is your rate. So it might be a percentage rate, and it's going to either be a growth rate if it's greater than 1. If it is a fraction or a decimal, it is a decay rate. And this will affect, if it's increasing or decreasing from left to right. And then your x term here is your step. So usually it's some type of time frame, days, months, weeks, once a year, whatever. But it's just your steps, and you're just exponentially increasing the growth or decay rate. So what do we know about this? Well, we know that this 8 right here, okay? So when we've got the y equals 8, 0.25 x, this a term, we know is your starting amount. We also can say it's the y-intercept, and it's probably going to be the y-intercept simply because we don't have a word problem here, we have no context. And then we know that we have a decay rate because this is less than 1. Right? So if I were to draw this, it would look something like this. Since it's a decay rate, right, it is going to be, let's put our y-intercept right there at 8. And we're going to kind of just decay like this. And it's going to kind of land something like that. Okay? So let's take a look at our answer choices. The coordinates of the x-intercept. Haha, there is no x-intercept. So here's the thing with most of your exponential functions. Unless you do something afterwards like a +7 to shift it up or a -9 to shift it down, this x-axis for just your vanilla exponential function, which this is your line of asymptote. So there is no x-intercept. That means this curve is increasingly getting closer and closer and closer, but it's never quite going to reach it. So there's no x-intercept. Now, coordinates of the y-intercept, yeah, 0, 8. Sure, that's exactly what we just said. The equation of the asymptote is x equals 0. Now, don't be fooled. X equals 0 is a vertical line. This is x equals 0. That's your y-axis. If they said y equals 0, that'd be correct. And then the graph includes the point 2, 1. Now, if you plug this in and you make a 2 right here, and that x, that actually equals 0.5, not 1 or not 2. So our answer here is G.